Today and this week, we'll be talking about 3D printing. So by the end of the session, the goal is for you to be able to describe the role of 3D printing in creating prototypes, understand the basic requirements for 3D printing processes. So that's everything from designing a 3D print to actually printing it with a printer and kind of knowing the ins and outs of changing filament and selecting filament and troubleshooting and all of that. And then to be able to list 3 ways that 3D printing could be used in clinical settings. So these are things that we just want you to be able to think about and keep in mind both during the synchronous and asynchronous parts of the lecture. So actually re-recording these a little bit later because we recorded this lecture at the beginning and then we wanted to add a little more asynchronous lab for you. So the session format is actually going to be about 45 minutes of asynchronous lecture. I will talk a little bit about 3D printing, and then Octavio, who you've now met a few times, will also provide a guest lecture showing you the ins and outs of printing, and it'll be supplemented by also a short YouTube tutorial where you can actually see somebody setting up a print, printing it, etc. And then we also added an asynchronous lab component. So hopefully this is fun for you. We're going to use Tinkercad tutorials, and I'll talk about those at the end of this section. And then during our synchronous time together, we'll actually have a guest lecture and Q&A with Rancho Los Amigos' Emerging Tech Lab Director, Andy Lin. So he works really closely with clinicians. He also works really closely with patients, and he fabricates all sorts of things using his 3D printer to meet whatever their needs are. So hopefully you'll enjoy that. And without further ado, I'll get back to the lecture. Okay, so this is our 3D printer. This is back in April or so. I brought it home once everything shut down. And what you'll see is it's actually printing out these, let me sound, you can hear the motor running. It's actually printing out these face shields that then will be fit with plastic and elastic. And we were printing basically PPE for the clinicians here at Tech. So as you'll see, as you can see from this, it's not super glamorous. The way 3D printing works is it basically lays down layers of filament. And so this is just one layer, but after it finishes this first layer, it'll go back and print a second layer on top of that until it reaches the desired thickness. Okay, so what is 3D printing really good for? Well, for one, it's great for prototyping physical objects, and especially for really rapid prototyping. So often it's a lot easier to just print out something made out of plastic than trying to, let's say you whittle it with wood or use steel or any other sort of device like that. I think 3D printing becomes a great option because you can actually design something. You can customize your design to have very precise dimensions and specifications. So for instance, in the case of these face shields, they all had to be identical in size. They had to have these little notches here, which is where the plastic was fit onto them with the face shield component. And then they had to have these like plastic loops at the back so that we could fit elastic through them. So that would be something that would be a lot harder if we had to do it with metal or wood, but it's pretty fast and easy using plastic. That said, fast means like one of these shields took about, I think, an hour and a half per shield. And that, of course, depends on the speed of your printer, the material, the thickness that you set it to, etc. But it's not instant. It still takes some time, but it is faster than if I was going to try to carve a face shield out of wood, for instance. It's also a great way to make samples of your idea in a relatively quick way, and it's relatively low cost, especially if you have access to a printer. So like one spool of filament, anything on the next slide, oops, on the next slide you can see, so like a spool of filament like this can cost $20 or $30. And for us, a spool printed about, I think, 20 face shields. So it's like $1 a shield. And that's, of course, again, a lot cheaper than if you were trying to fabricate something very specific from scratch. Okay, so in terms of what's required, you usually want to have a 3D design or model of what you want to print. So, we've worked a little bit with the software side. Probably the closest thing that you've experienced are the 3D objects from Unity. So those 3D objects are all designs or models in 3 dimensions. And you would use a different type of software specific for 3D modeling. So there's a ton of different ones. There's like Blender, Maya. There's a lot with the word CAD in them because CAD stands for computer aided design. So you basically just want to take whatever it is that you want to print and make a model of it in 3D on the computer first. Then you also need a software that will let you slice that model. So you have a 3D image. So in this case, this is the octopus. This is like the design model that comes with our 3D printer, which is the Lulzbot Taz. And it's kind of like the first print that they ask you to try out because it's relatively complex, but it should always work. And so you have this image as a model, and then you put it into software to slice it, for instance. So you say like how many layers you want, how thick you want the layers to be, etc. It basically gives instructions to the printer on how exactly to print it. You then, of course, need some way to connect your design and slice parameters to the 3D printer. So for instance, with the Lulzbot Taz, there's a HDMI cable, so you could plug in a laptop to control it. There's also a slot for an SD card. So sometimes we'll just load a bunch of designs onto the SD card that already have print parameters specified. And then we can just use this print display here to toggle through some of the switches and select which design you want to print. There's also, of course, the filament, like I mentioned, and there's tons of different types of 3D printing filament. I think as time goes on, there become more and more. And I will also say that this type of 3D printer that we're talking about right now and that you'll see from our lab is one of the more basic 3D printers. I think now there's tons of different ways to do 3D prints as well. But this is really just kind of like the standard old school 3D printer style. And then, so you can choose different filaments based on what properties you need your print to have ultimately. So it can be more or less flexible and malleable. You may want it to be really rigid. You may want it to be a little bit softer. And so you can choose that. You can obviously choose the print filament colors and all sorts of things like that. And then there's also filaments that actually dissolve in other chemical solutions. So sometimes you need supports for your design. And so you would print with a filament that will dissolve later on for the supports if you intend to remove those parts. So it can get really complex, but for the most part, we tend to print things that are pretty straightforward. And then finally, you obviously need a 3D printer itself with all of its different components. So here it's showing you the filament. This is the kind of the magic, the motor. So the filament feeds into the motor. There's a hot end, and this is called the extruder. So it's actually going to melt the filament down from the solid plastic into like a liquid form just briefly as it lays it down, and then it'll land on the print bed, and then it will cool on the print bed into whatever the hardened form should be. And then there also has to be a cooling fan so that this extruder doesn't overheat. So those are probably the primary components, but there's a lot more to it. There's also a power supply, of course, and other things. So given a design, a 3D printer prints or extrudes thin layers of filament that build on one another. So here's the video again. So you can basically think of the printer as like a normal, like your regular paper printer, except instead of laying down one layer of ink, it's laying down one layer of filament. And then what makes it 3D is that it builds on that layer of filament upwards. So it'll keep going in the Z dimension essentially, so that you end up with a 3D figure or model. And then you can also specify things like the amount of filament, the temperature that the filament comes out of the extruder, the print bed, and the thickness of the layers in order to create a really good design. Okay, that said, there are of course a lot of limitations with 3D printing, and maybe you'll see some of those, maybe you won't. But because you are always building up layers, the model does need to be printed contiguously. So that means that it should always have be touching the layer prior to it somehow, or have supports that can be removed after. So one example, for instance, is this object, which has an overhang right here, because it's printing back and forth like this. And then when it gets to this part, it doesn't actually have any support for it. So when it prints, the filament just kind of droops down and around because it doesn't have anything to support it. And that's what creates this kind of messy spaghetti-ish thing that you'll see over here. 3D print spaghetti is very common, and we get a lot of that as we are developing the right parameters for printing. And then the settings matter a lot. So we play around a lot of times with the temperature of the extruder, the temperature of the bed, the type of filament, and the slice thickness or the layer thickness, because all of that can matter a lot. So here's a good kind of a meme, but it's also just true. If you don't have the right settings, you're going to have a bad time. So this could be your 3D model, but if you don't have the appropriate settings, this is what you could end up with, which is just like a mess of plastic filament pieces. So thin layers, detailed non-contiguous designs, etc., all of that can be super tricky to print. And then another limitation is that the object size has to be smaller than the print area, obviously. So those are some things that you want to consider when you're thinking about what you might want to print. Octavio is going to show you some of the things that we print in our lab. They tend to be like boxes, like solid objects. Even things like this you can print actually, but the design, in this case, if this is what you wanted in the end, you should just flip it upside down so it prints the solid like top part first, and then it can print this on top of that because that will make for a much better print design in the end. And then when it's done, you take it and just flip it back the other way. So there are, of course, a lot of limitations. Like I said, again, this is what we get so much of the time, tons of random pieces of filament that we end up throwing away. But troubleshooting is really important to make sure you get the right conditions and specifications. That part can take a while. There are, however, lots of online forums. I think as you're learning with every technology, there are tons of forums to try to troubleshoot and help you figure out the best way to do things. There's a lot of like workarounds and solutions. So things like how to calibrate your printer if it seems like it's crooked or it's not printing right. Sometimes we use painter's tape, which is what you saw on one of the videos, and or we can put like a glue stick on the print bed for better adhesion for that first layer of the print and things like that. So overall printing is very exciting. There's lots of things you can do with it, but it also requires quite a bit of trial and error and patience and having the right design and the time to get the settings right. Okay, so hopefully after hearing that and during the rest of this lecture, you'll think about some things that you might want to 3D print and why. So thinking about the feasibility of your idea, and especially as Octavio shows you the ins and outs of 3D printing, thinking about what's feasible and what you can actually do or not. And you may also want to consider this in our live session when we'll have the lecture and Q&A and ask some questions, and you can maybe propose some ideas and things like that as well. Finally, I wanted to tell you a little bit about the hands-on lab. So after you listen to Octavio's lecture, you will do some lab for the asynchronous portion. For this, we're actually going to have you learn how to design a 3D print using Tinkercad. So first you'll make an account on tinkercad.com. Then you will complete the basic Tinkercad tutorials. So these actually are not videos for once. They're embedded into Tinkercad. You can click this link or just click learn and then designs and learning. And then there will be an option called starters. And starters basically will walk you through quick tutorials like placing an object, copying an object, duplicating it, changing the shape, rotating it, etc. And it's, again, not videos, it's just instructions on like the left-hand side, and then you do them, and then you'll go to the next one. After you do that, you will watch a 10-minute Tinkercad tutorial that will show you a little bit more advanced knowledge about how to kind of manipulate things. You can follow along if you want, but you don't have to. It's just to introduce you to some of the controls in Tinkercad. And finally, we'd like you to try this tutorial. It's only a 3-minute video, but as we've talked about, sometimes 3 minutes on video actually means longer when you're trying to do it yourself. So it should probably take you about 15 minutes, but it will allow you to design a 3D printable mug. So those are some things that you can try. Because some of you have also asked, like, if I like it, can you give additional resources? So if you like Tinkercad, you could also try Tinkercad's lessons. Those are, again, embedded in the Tinkercad website, but there'll be things like where you pick the end product you want to make, like Minecraft glasses and other sorts of things. You can also look for YouTube tutorials So Chaos Core Tech tutorials are ones that I had started watching when I was learning a little bit about Tinkercad, and they have a whole playlist just for Tinkercad tips and things. Another fun thing you can do for 3D printing is browse thingiverse.com. So this is actually a website where the public, everybody in general, will upload 3D prints that they've created or models of 3D prints, and you can download them and you can try to modify them. So that's kind of a good way to get started without having to do it from scratch. And the last thing is you could try to create your own model from scratch depending on what you want to make. So there's video tutorials you could find, for instance, on how to make like a phone holder or I don't know, all sorts of things basically. And so if you do that, you can send us the model and that would be part of your extra credit. And if it's within about 5 inches all the way around, we can actually try to print it for you. So the final note I want to say is that Tinkercad is great for beginners, which is why we have it here. If you think you're going to get really serious about 3D printing and it's something you want to be working with and using a lot in the future, you may want to learn a more flexible software like Blender. That's one of the types of softwares that Octavio shows working with in his video. But all of the kind of like more flexible, more hardcore 3D printing softwares do take you down a little bit of a deep rabbit hole. So they are the types that have a pretty steep learning curve, which is why we didn't want to use it for this class initially. But that's just a side note in case you do decide that it's something that you really love and you want to get more into it. So I hope you enjoy this unit. We will have a quiz at the beginning of class for the synchronous portion as usual, and then we will jump right into the guest lecture with Andy Lin. Okay, thanks so much, everyone.
Hello, everyone. My name is Octavio Marin Pardo, and I am a biomedical engineering PhD student working in Dr. Liu's laboratory. I did my undergrad studies in mechatronics engineering, which, among other things, included training in several manufacturing processes. Here, my research is centered in biofeedback of muscle activity to promote recovery of the upper limb after people had a stroke. So, to work on that, we developed a system that we could send to people's homes for remote tele-rehabilitation. This required to design and manufacture cases for our sensors and electronics. And today we're going to talk about 3D printing for healthcare prototypes. As a brief overview, we will be focusing on the clinical applications of this manufacturing process. We'll talk about a little bit about product design. We'll discuss some 3D printers and filaments that we can use, and also overall the whole 3D printing process, from preparing the file to printing and troubleshooting. As Dr. Liu explained, this manufacturing process essentially consists in creating three-dimensional objects by consecutively adding bidimensional layers of material. For this presentation, we will focus on a process in which we melt plastic in specific coordinates to create the layers of the object. However, please keep in mind that there are other processes available that allow for different costs, precision, manufacturing times, and materials. Current technology allows us to print for a wide range of applications, including pieces of metal, artificial tissue, and even buildings. Since it's cheaper and easier to use, plastic is perhaps the most commonly used material in 3D printing, either alone or in composites of polymer with other things like wood, fiberglass, and carbon fiber. So, some of the clinical applications include whenever we need to do fast and cheap prototypes, like having something for a showcase or doing product development or to design and optimize something that we would like to produce, like this EEG helmet. That's something where we can use 3D printing. Another application is to manufacture devices or equipment that, for example, do not need to be too sturdy, like a sensor case, will be disposable, like personal protection equipment, or needs to be resistant but has a complicated geometry, like prosthesis. Some of the more advanced and new technologies allow us to print even artificial tissues. So before talking about printers and materials, let us consider what we need to know before making choices. As any other manufacturing method, 3D printing is a powerful tool, but as Dr. Liu mentioned, it has its limitations. As a very brief overview, the design process starts with the conception of an idea, a product, a device, a system, or even the process that we want to create. First, we need to identify the needs of the people who will use it. Then we brainstorm possible configurations that will solve those needs, including the physical properties of our product, what materials we will use, and how we will manufacture it. Then we refine our design with the known limitations and constraints, and we develop prototypes, test them, and modify everything that needs improvement until we have a finished product. It is important to note that this is not a linear process. Most steps require iterations, and if something doesn't work, we need to go as back as necessary to get the solution that we need. So from the moment we think, I want to make something, it is important to consider a couple of things, such as what is the purpose of this product, who will use it, how is it going to be used, how is the environment where it will be used. All of these things gives us important information about the required sizes, materials, durability, and so on. Finally, we also need to consider what we could be our limitations. For example, the printer that we have access to, the material that we have or absolutely need to use. What is our budget? Or if we are planning to buy a 3D printer, what is our available space and how we plan to use it in the long run. Some of these requirements will restrict others. For example, the maximum size of our printed object depends on the size of the printer. And some materials require specific printers or specific heads. Here we can see some examples of 3D printers with prices ranging from a couple of hundreds of dollars to several thousands. Differences between them are in terms of sizes, materials they can use to print, the precision they can reach, the quality of the print, if they have some form of environment control, and things like that. One of the key pieces of the 3D printer, just as regular printers, is the head. So a typical printer head is comprised of the hot end, the cooling fans, and a gear and a bearing. Here we can see a close-up of the arrangement. Essentially, when the motor turns, the bearing and the gear push the filament through a heating chamber where it melts. Then the melted material is pushed through the nozzle. The printer software not only controls the movement of the bed and the height of the head, but also the movement direction and the speed of this motor. By turning in one direction, we extrude material, and by turning to the opposite one, we will retract a little bit of the melted plastic. Here we can see that the hot end contains a heating element, a temperature sensor, and the nozzle. With the printer software, we can control the heating temperature. Most filaments work with temperatures around 200 degrees Celsius, which is good for most prototypes. However, depending on the material that we are using and sometimes the geometry that we're printing, we might need finer control, adjusting both the temperature of the heating element and also the speed of the fans. Not enough temperature could impede the addition between the layers or not melt the material at all. Too high temperature might degrade the material and compromise the strength of the object that we are printing, or even burn the filament. For most applications, these parameters are pre-configured in the software, but we have the liberty to change them if we need to. An important note here, printer quality is highly dependent on the height of the printed layers, and this will depend both on hardware and software. With software, we can control how much the C motor will move between one layer and the next. In terms of hardware, things like the material composition, the diameter of the filament, the nozzle size, and the calibration of the printer bed will have a great impact on the layer height and consequently in the quality of the print and the addition of the first layers. As we will see, the layer height will play an important role in the strength of our print, how much material we use, and how long the print will take. Different printers allow to use different printer heads, and consequently what materials we can use. Here we can see a head that can extrude 2 filaments without necessitating to stop one print to change them. This is useful not only to have different colors in a single print, but also to use 2 materials with different properties. For example, we could have a tool that uses hard plastic as the structure and also soft plastic for a better grip, or a piece with a geometry that is too complex and requires to print support material. With a head like this one, we can use support material that is easy to remove or even soluble in water. Now, the moment we've been waiting for, how to print. First, we need to have something to print and choose the material that we will use. Then we prepare our files to print. And finally, we configure the printer and start the print. So, step number 1, filaments. How do I choose? Well, that depends on the needs that you have. As we saw in the design process, this is the very first stage and the beginning of our whole design. So things like the strength that you require, the precision, flexibility, if it needs to have high or low friction, if it needs to be resistant to chemicals or water, do we care if it's toxic, the plastic, meaning like if we're planning to use it to hold food or something like that. Another more aesthetic things like the color or if it's transparent or something like that, those will be the kind of things that we need to take into account to define what material we're going to be using. So this will restrict some of our choices because different materials provide different properties. Here are some examples of the most common ones that we can find in regular websites. PLA is probably one of the cheapest and most common filaments that we can use, either by itself or with other things like magnetic iron, stainless steel, conductive material, or even wood. We can also have materials that allow us to print molds for casting, or things like CPE for added toughness and chemical resistance. Nylon is also a very common material for these kind of things because it has increased strength and durability. And also we can add fiberglass to that filament to make our design even stronger. Other filaments available are flexible filaments that, as the name suggests, print a piece that is flexible to manipulate. Now, about the object itself, it is possible that what we want to print already exists. Things like keychains, toys, and tools are easy to find in the web. So a good first step is to look for existing designs on the internet. For example, with the events from last year, the maker community united to create and update different solutions for the personal protection equipment scarcity, releasing free of charge dozens of designs of masks, face shields, door openers, and so on. So we can look in the internet for something that fits our needs. However, we need to download the correct files. Compatible files will depend on the printer software that we are using, but some of the most common are OBJ, 3MF, X3D, and STL. However, some programs can also convert image formats to something printable, like BMP, GIF, PNG, and JPG. However, if our application is specific and our needs doesn't comply with what we have available in the internet, another option is to create our own objects from scratch. As Dr. Liu mentioned, there are different programs for animation, engineering, and design that we can use for this. Here is a quick example of using Solid Edge to create the boxes that we used for our sensors. For example, we can see that we start with bidimensional designs, and then we create solid objects, and then we make edits like holes and protrusions to the already created layers to have a finished design. Here, for example, after we have a box drawn and expanded, we can add a little hole for the cables to fit in. Then here we can see an assembly of the two finished pieces with the sensor inside. Once our files are ready, we can save them in one of the supported formats, for example, STL, and then go to our printer's software. But first, if we already have a design and we have access to the original file, we can make edits to that previous design. Here, for example, we are increasing the size of a couple of holes in a different case. This was because after, as I mentioned, the design process is iterative. So we first printed one case, and then we realized that the holes were not big enough. So we went back to the design and made some adjustments. Now, to learn how to add the filament and prepare a printer, let us watch a couple of videos from people using the printer that we have in the lab. All right, now that we have watched the video, I will add a few things. In the last part, he mentions something called G-code. That is a text file that contains all the instructions to print our object. It starts with some configurations, like moving the head to initial position, hitting the bed and the hot end, and then setting the first printing speeds. Then each subsequent line is an instruction to move to a specific coordinate while extruding some material. Modifying this file is not recommended unless you know exactly what each line means, but this is what the printer is using to create our object. So the printer then reads line by line and builds our design object from these instructions that we just saw. Here is an example of the printer printing the lead of one of our design sensors. Right. So as you saw in the second video, we can also select from the material list the type of filament that we will use. These will predefine some properties for our print, like the default temperatures, the fan speeds, and so on. However, in the advanced menu, we can also modify those if we need to. Furthermore, we can save in each profile or modified configurations. Here, for example, there are a couple of pictures to compare what the defaults print. The first thing that we can note is that the higher the detail, the thinner each layer will be. For example, in each one of these was printed with one of the three predefined profiles. This would be for high detail, this for a standard print, and this for high speed. As I mentioned, what we can see is that the higher the detail, the thinner each layer will be. This will not only increase the quality and the strength of our print, but also will take a bit longer to complete, and also will require more filament. We can also see that this is, again, an example of the high detail print, and this would be with high speed. We can see that details are higher the more material we use. So, as I mentioned before, the custom settings allow us to change all printer properties from the temperature of the bed and the nozzle, the layer heights, the fan speed, the extrusion speed, how the support will be created, and so on. For the most cases, the predefined configuration should work just as fine. However, some designs might require adjusting things until we reach the configuration that gives us the best results. As many things in life, practice makes perfection. One more thing that we can customize is the infills. In the video, we saw that we can change how much material we will be using to fill the inside of our piece, and that the more we use, the stronger it will be. However, this will also increase the weight of the object, the amount of material required, and the time to complete the print. So another strategy is changing how we are filling the inner space of the object. Here we can see some example. Each configuration will change the mechanical properties of our object, and it's important to consider that some experimentation may be required to see which one best suits our needs. Finally, at this point, you are now experts in 3D printing materials, configurations, and infills. Nevertheless, still, stuff happens, and we get unexpected and undesired results. If, for example, the printer does not print, we can look for things like, is the temperature adequate for this material? Is the nozzle clogged? Is the filament loading? If everything seems to be okay, it might be that our filament is not getting into the heating chamber. Let us bring an old picture. Here, what it should be happening is that the filament is going through this plastic piece and then entering this metal one. So when we load the filament, we insert it through a hole in the plastic piece, and then it reaches the metal one. However, if, like in this printer, the plastic piece is slightly bigger than the metallic one, here, close-up of this, the filament might be stuck between the two materials. So reloading the filament will fix this issue. Once the hot end is at the right temperature, a slight push should extrude some plastic. So moving the filament around until you see melted plastic coming out should fix these kind of problems. Now, if the base of the object or the first few layers of the object are detaching before the print finishes, there are a few things that we can try to fix our next trial. First, by software, we can add brims or rafts to the first layer, as we saw in the video. Or also we can, if our design includes overhangs, we can try rotating the object or adding support material. Other solutions are in terms of hardware. For example, we might need a higher friction coefficient between the printer bed and our object. So adding something like printer's tape might just be the trick that we need. One last option would be adding a little bit of glue stick to the printer bed before starting the print. Some filaments might actually require to do these kind of things. Fine. Let's see some advices that I can give as part of the experience that I had from using this kind of technology. Something that is good to remember is that we need to let the piece cool before moving it from the bed. If we remove the piece before it has reached room temperature, we could, without wanting to, we could just bend the piece. Some materials or designs might require post-processing, like manually removing material, like just by removing these pieces of plastic, or we could even need to sand a little bit to make it a little less rough on the edges. Another thing, the designs that we use might not be within the limitations of our printer or the material or the configuration that we're using. Here, for example, we can see that while trying to print holes in the design, the hole might be too small for the printer to handle. Another possible source for this kind of error is that we were retracting too much plastic between one circle profile and the next. So if, regardless of the material, design, and printing properties, things seem still a little bit off, it might be necessary to recalibrate the printer, or cleaning it, or lubricating or fastening some screws. So That's everything from my side. I hope this served as a good exposure to the fascinating world of prototype creation. So thank you very much and happy printing.